Now that I know how to take derivatives of vector-valued functions, let's look at integrals of vector-valued functions. Once again, let's start with r of t is xt times the I vector plus yt times the j vector plus zt times the k vector. Then the integral of r of t is the integral of the individual pieces, the integral of x of t times I plus the integral of y of t dt times j plus the integral of z of t dt times k. Let's consider the vector-valued function r of t equal to 4t cubed minus 8, 7 cosine t, and e to the t plus 1. And I want to find the integral of r of t. Let's start with individual pieces. Let's consider the integral of 4t cubed minus 8. The rule for integration with exponents says to add 1 to the exponent and then divide by that number. 4 divided by 4 would be 1. The integral of negative 8 is negative 8t, and we need to add some constant c1 to the end. So this will be my first piece for this integral. Next, I need to take the integral of 7 cosine t. The integral of cosine is sine, so this is 7 sine of t plus a constant, which I'm going to denote by c2. So my second component, 7 sine t plus c2. My third component, e to the negative t plus 1. The integral of e to the negative t is negative e to the negative t. The integral of 1 is t, and we have a third constant here, c3. So this is negative e to the minus t plus t plus c3. So here is the integral of my vector-valued function. Let's consider the velocity vector, 4t cubed cosine t negative e to the negative t. And we know at time t equal to 0, the object is at the origin. So we want to find the position vector. The position vector is the integral. The integral of 4t cubed is t to the 4th plus c1. The integral of cosine of t is sine of t plus c2. And the integral of negative e to the negative t is e to the negative t plus c3. From there, we're going to use this information. I'm going to plug in 0. 0 to the 4th is 0, so my first component is just c1. Sine of 0 is 0, so my second component is just c2. E to the negative 0 is 1, so my third component is 1 plus c3. And I know that this should be the origin since I start at the origin. Using this, I get c1 is 0, c2 is 0, and c3 must be negative 1. That's what it will make this vector 0, 0, 0. So my actual position vector, t to the 4th, sine of t, e to the negative t minus 1.